It is desirable, in order to maintain the vibration economically, to reduce the impact and frictional losses as much as possible. As regards the latter, which in the electrical analog correspond to the losses due to the resistance of the circuits, it is impossible to obviate them entirely, but they can be reduced to a minimum by a proper selection of the dimensions of the circuits and by the employment of thin conductors in the form of strands. But the loss of energy, caused by the first breaking through of the dielectric, which in the above example corresponds to the violent knock of the bottom against the inelastic stop, would be more important to overcome. At the moment of the breaking through, the airspace has a very high resistance, which is probably reduced to a very small value when the current has reached some strength and the space is brought to a high temperature. It would materially diminish the loss of energy if the space were always kept at an extremely high temperature, but then there would be no disruptive break. By warming the space moderately, by means of a lamp or otherwise, the economy as far as the arc is concerned is sensibly increased. But the magnet or other interrupting device does not diminish the loss in the arc. Likewise, a jet of air only facilitates the carrying off of the energy. Air, or a gas in general, behaves curiously in this respect. When two bodies charged to a very high potential discharge disruptively through an airspace, any amount of energy may be carried off by the air. This energy is evidently dissipated by bodily carriers in impact and collisional losses of the molecule.